Hello everyone, you are viewing the lecture of Antenna and Propagation, subject code 6EC404, prepared by Ruchi Sharma, Assistant Professor from EC Department, Arya College of Engineering and IT, Jaipur. Dear students, in this lecture, this is lecture number 5, and in this lecture, we are going to learn about topic number 5.4, which is Smart Antenna. You are going to learn what is the smart antenna and how it is different from the traditional antenna types. Now, smart antennas. This name smart antenna is derived by when we use antennas with the combination of digital signal processors, means to make the antennas work smartly. We are combining the digital signal processors with the antenna arrays in order to enhance and optimize the performance and efficiency of the receiving systems. So, smart antennas are array of antenna elements that change their antenna pattern dynamically to adjust to the noise interference in the channel that affects on the signal of interest. In the sense, by using smart antennas, the interference which occurs between a user and the transmitter of the base station, the interference is eliminated to a huge extent. Means the smart antennas works like, just suppose in a cell, you must have learned about wireless communication, cell sectoring and all. Suppose in a cell, if one user is existing and the antenna is radiating in all the directions, then it is the wastage of energy. Like where there is undesired user, where there is not desired any radiation, it is also delivering in that location also. So in contrast to that, smart antennas work like, where there is the location, the fixed point at where the user will be, the antenna will judge the location, will calculate the location, and will be able to radiate effectively in that particular direction only, which eliminates the interference to a huge extent. So, smart antennas are not smart, although it's the digital signal processors along with the antennas which makes the antenna smart. Now, smart antenna systems are basically an extension of cell sectoring, in which the sector coverage is composed of multiple beams. It is the extension of cell sectoring. Now, when we compare the smart antenna analogy with human, like if we blindfold and we get blindfold and multiple n number of people are speaking, and we want to hear only a particular person, then in the presence of multiple number of voice, we are unable to distinguish between the desired voice. Okay, in contrast to that, the smart antenna works smartly, that is, it judges the desired speaker, it judges the desired user, and radiates it beams steers in that particular direction only, thereby eliminating the interferences, and it is also providing the benefit to the wastage of energy, wastage of energy in the other undesired directions. And with the help of the DSP, digital signal processors, the antenna array is able to steer its beam width. Okay. Now there are basically two types of antennas: switched beam antenna systems and adaptive array antenna systems. Both have, first, switched beam antenna system. There are some drawbacks in the switched beam antenna systems, which is covered under the adaptive array antenna systems. Now, switched beam antenna systems, it is the extension of cell sectoring, as each sector is subdivided into smaller sectors. There are basically three axes orthogonal to each other, which is x, y, z, and each plane x, y, y, z and x, y, x, z, it is these three planes are divided into 120 degree angle, and further it is more divided into n number of angles, and sectors are created with where each fixed directive antennas are placed. Now, why it is named as switched beam antenna systems? we'll get to know that the overall goal of the switch beam antenna system is to increase the gain according to the location of the user. Means switched beam in the sense that suppose that user number 1 is standing particularly in a particular direction, and if it moves, then the beam which is transmitting in that particular direction also moves with the user. So this is the aim of the switch beam antenna systems, which is to provide the network in whatever direction, in whatever location the user is moving. This is the diagrammatic representation of how switch beam antennas look like. Now we come to adaptive array antenna systems. In contrast to switch beam antenna systems, when we talk about adaptive array antenna system, the system capacity increases to far extent. Means in switch beam antenna system, the antenna is limited at a point where it is restricted that um, it can't provide an user more than a limit. It can't provide signal strength very efficiently to the user when it extends continuously. Now in adaptive array antenna system, when you increase the n number of users, it also provides signal to each of them, thereby the coverage area and the capacity of the system also increases. Now what it principally does, it is the adaptive array systems which can locate and track signals, users and interferers. Okay, and what it does, it dynamically adjusts the antenna pattern to enhance reception while minimizing or fully rejecting interference using signal processing algorithms. Now this is the difference between switched beam scheme and adaptive scheme. You can see in the switched beam that it is provided the same intensity of signal is provided to 8 sectoral regions, and user interferer both are getting the same intensity of signal. And here in adaptive scheme, you can see that interferer 1 and interferer 2 are receiving nulls, and whereby user 1 is dedicated with a major beam. This is the block diagram of adaptive array antenna, how it looks like. See, this is the down converters, and these are the digital signal processing box where whole the signal is digitally processed. This is the main differences between switched beam array and adaptive array. In switched beam array, there is less coverage and low interference rejection, whereas in adaptive array, there is more coverage, high interference rejection, and reduction in the transmission power. The transmission power is also reduced to a great extent. Now, this is the transmitter of the smart antenna. This is the receiver. And what are the benefits? The first ever benefit is that the capacity of the system increases, and it also provides increase of range, that is more directional than omnidirectional and sectorized antennas. It is obvious. And another advantage is the system security. Interferers are completely eliminated, and they can also be used to locate humans in emergencies. Now, the main applications according to the nature of the working of these smart antennas are as follows: cellular and wireless networks, radar electronic warfare as a countermeasure to electronic jamming. Means ki it can behave as radar tracking systems, and also for the satellite systems. What are the drawbacks? The transceivers are much more complex than traditional base station transceivers. The transceivers which are attached in the smart antennas are more complex in nature as compared to the traditional base station transceivers. And the smart antenna base stations are must be equipped with very powerful digital signal processors. The digital signal processors must be very powerful, and further it is obvious that it will also increase the cost of the overall system. So this is all for this today's lecture. Thank you.